Okay, so in section 5.6, you're going to be doing some review of exponent rules. So I'm going to run through those with you pretty quickly here and look at an example of each. And then if you have not done it before, you're going to be looking at putting numbers in scientific notation as well as taking it out of scientific notation. So first thing, let's run through the exponent rules. The product rule tells you what to do with your exponents when you have two things that are being multiplied. And the key here, the really important thing to note, is this rule only works, and really all of these exponent rules only work when you're dealing with a common base. All right, so the general product rule says if your bases are the same and you are multiplying two things together with exponents, then you can keep the common base and add the exponents together. All right, so an example of that here, notice these both have a common base, and as you know, if there's no exponent showing, it's assumed to be a 1. So I look at this, I see the bases are the same, I keep the common base, and because they're being multiplied, I add the exponents together, and this becomes 5 to the third power. And if I use my calculator to evaluate that, that's going to give me 125. All right, so that's your product rule. A couple other examples for you to try and check with the completed notes later. All right, that brings us to the quotient rule. So this is, dividing is the opposite of multiplication. So if we add the exponents when we're multiplying, then we will subtract the exponents when we divide. All right, just the opposite. So again, always make sure you have a common base, all right, which that happens here. Keep the common base, and when you are dividing, you just subtract your exponents. So this would become 3 to the 4th power. And again, I can use my calculator here to go ahead and evaluate that. 3 to the 4th power tells me this is going to equal 81. All right, so that's our quotient rule. Our power rule tells me what to do when I want to raise one exponent to another exponent. All right, so here's our general rule. And when we are raising one exponent to another exponent, this is when we multiply the exponents together. All right, so let me come over here to this one. So you've got 2 to the 3rd power. There's one exponent. And then you want to raise all of that to the 4th power. So an exponent to an exponent, keep your base, multiply your exponents together. That tells me this is going to be 2 to the 12th power. And then again, if I use my calculator, 2 to the 12th power is 4,096. All right, so again, when you're multiplying, add the exponents. When you're dividing, subtract the exponents. When you're raising a power to a power, multiply the exponents together. All right, our next rule here tells us what to do with negative exponents. And what you want to think about is anytime you have a negative exponent, number one, you don't ever want to leave your answer in terms of a negative exponent. All right, what a negative exponent will do is it will change the location of that term. Meaning if it's on the top of the fraction, it will move to the bottom and become positive. If it's on the bottom of the fraction, it will move to the top and become positive. So in general, okay, here's our general rule. Anytime an exponent is negative, I'm going to move it. So this one is in the numerator. That means I'm going to do 1 over, and when I move it, the exponent becomes positive. All right, so 2 to a negative 4 power. I'm going to move it to the denominator, and when I do that, what happens to my exponent is that it always becomes positive. All right, so 2 to the positive 4, right, we can evaluate that as 16. It's just because that 4 was negative, the 16 gets moved to the denominator, and this evaluates as 1 over 16. And if you're working in a more general form, like up here you have one in terms of x, it works the same way, you just can't evaluate when you get to the end. So like here, the first thing I would do is I would notice, okay, this is dividing. Common base, right? And I'm dividing. So that would tell me to use the quotient rule, right? Which says you keep the common base, and when you're dividing, you subtract your exponents. But notice when I do that, right, 3 minus 7, right, we talked about dealing with positive and negative numbers. This would become plus a negative 7, and that means my exponent here is going to be a negative 4. And this is where you don't ever want to leave your answer with a negative exponent. So what you're going to do is move it to the denominator, and then that will make the exponent positive. All right, and then your last exponent rule here is to remember anytime you have a 0 exponent, the answer will always be equal to 1, and this is no matter what the base. All right, so like if I had negative 4 to the 0 power, as soon as I see that it's the 0 power, it equals 1. If it's just a general variable x, 0 power always equals 1. If it's a fraction raised to the 0 power, always equals 1. All right. Now, do be careful again with parentheses. So just a little side note here. If this had been negative 4 to the 0 power, right, parentheses are important, the negative is not being raised to the 0 power. All right, so that negative would trail along here. 4 to the 0 power would be 1, but the negative would stay because it's not inside parentheses. All right, so what I want you to do now is I want you to go into section 5.6 practice, and I want you just to practice the examples that are dealing with the rules of exponents, right? Do some good practice there. Hold off on scientific notation. Do some good practice with your exponent rules, and then I want you to come back and watch the second video for this section where I'm going to walk you through scientific notation.